Years ago, people are still use paper map to navigate and locate themselves when they are in some unfamiliar places. Today, these tools are replaced by various applications in people's mobile devices and make people's life more convenient. These applications are quite useful when people are outside. However, in the indoor environment, the applications are not helpful anymore. Therefore, how to get indoor location has drawn tremendous interest recently. Unlike outdoor localization, indoor localization does not rely on GPS and cellular tower to locate users. Due to the concrete structure and the wall will affect the signal, and the GPS is also unable to know the indoor structure exactly. After we put forward our idea and motivation, the next step we need to do is to analyze the user experience and come up with what users really need. Therefore, we use some UX design methods such as questionnaire and experience sampling to know the user's need and the reason why the current product is hard to use. From the literature review, we can also find the difficulties of the current technique. During the design phases, we divided several use cases to meet users' requirement and look for the most appropriate technique to make sure the usability of the system. For common user, they can take the device which has our application and verify their location. For the users that are inconvenient to carry a device, the indoor sensor could be installed at home and to detect and calculate their movement.
To figure out the user requirements, we have designed a questionnaire with various types of questions. Firstly, we recruit 50 participants through the public advertisement who have at least 2 years experience in using navigation. And there are some questions about scenario, like when and where to use, and some questions about performance or design in terms of accuracy, speed, and easy to use. According to the questionnaire result above, we have developed a design space that includes 2 dimensions. One is device, which includes phone, tablet, watch, glass, and other devices. The other is technology used in our study. The user requirement shows the phone is the most popular device among the participants. So we decided to develop an app for this application. As the indoor environment is limited, we chose Wi-Fi and location recognition as the methods to implement our application. 2 models were utilized in our implementation. One is RSSI detection model, which captures the signal of the user and estimates the relative location to the wireless points based on the signal strength. It is convenient for users when entering the building. We have also built a deep learning module that enables us to recognize the location of the photo the user uploads. Using this model, we can locate the user and provide navigation data by nearby photos.
The location system could be used in 3 different general scenarios. When people are at home, they usually do not carry devices with them. Therefore, the location data is mostly passive method, and the users are located by signal among the Wi-Fi devices at home, such as trajectory recording. When people are in public places, the system locates them based on the interaction between the router and personal devices, such as finding a room in the building. Except for these 2 scenarios that show the location to users explicitly. The locations can be seen as a tool to provide other service, such as energy management service or monitor the movement of elderly people. This is an indoor location service in the shopping center. And this is a home gateway unit that collects and processes the location data. As we can see in this form, for specific scenarios, the localization methods are various. In the shopping center, the user's requirement is to go to a certain store, finding a restaurant, or finding a toilet, and the user always take a device with them. Therefore, when user connection information is detected by sensors of the different floor, the iconography of the current floor can be sent to the user. In this condition, the application just needs to ensure the accuracy by install more signal detector and fuse the active and passive data. The second use case scenario is in the university. In the university, the user intends to find a lecture theater, office, or seminar room which has a room number. Therefore, the navigation of each room should be based on the Wi-Fi router and sensor in every room. If the user's device is connecting to a router, which means the user is near the room. The third use case scenario is a location monitor at home. The scenario is based on the passive RSSI location method, which refers the target of the monitor does not need to carry a device. The Wi-Fi routers in the house and the smart plugs can be installed in the house, and the wireless links among them enable RF coverage in the whole monitored house. The signal strength between Wi-Fi nodes could be affected by the movement of the object or people. Besides, the signal path could also help determine the location. The measurement of the angle of arrival can help to enhance the accuracy. The fourth use case scenario is in the hospital. We use a combination of both the active methods and the passive methods. For patients in the common zone, we give them a band to receive and send the signal. For patients in the individual zone, we locate them through the passive method by a sensor in the room. The machine learning part of the system is based on the pattern recognition, and it could be used in both indoor and outdoor situations, which require a large amount of image to recognize users' location.
One of our popular methods is based on Bluetooth beacon location, like the iBeacon produced by Apple company. With the help of single or multiple iBeacon base station, the smartphone can get the general location on the map. In this way to regulate the route and navigation. However, due to the fact that transmission distance of Bluetooth is relatively short, this will lead high cost of deployment and maintenance. Comparing with the Bluetooth method, Wi-Fi is more common for the indoor environment. Similarly, this method mainly applies wireless signal attenuation module and the triangulation location method. Due to the complexity of the indoor environment, Wi-Fi signal can be easily influenced by indoor environment, and it can be changed as the changing of indoor environment. In this way, the deployment and maintenance are still obstacles that need to be optimized during the process of utilizing Wi-Fi technology. There should be a trade-off between accuracy and cost. Balancing these elements can make the Wi-Fi indoor navigation technical more available and reliable. The future research direction is recommended with a low-cost plug and play and extending easily. The idea of indoor navigation with the basis of magnetic force sensor data from the different location can utilize the sensor extremely high limit. The main idea here is about magnetic information that can be disturbed by the structure of the building. For example, an application called Xunlu made by Microsoft Azure Group by acquiring the magnetic field information during the moving path and recording the relative movement orbit to generate a reference routine to users. So it provides a completely plug and play indoor navigation service that does not require maps or any other additional equipment. Location-specific features extracted from sensory data are combined with users' or walking patterns. For instance, steps, turns, going upstairs or downstairs to build reference trace that can be pushed to the cloud and shared with others for navigation purpose. During recording, you can take a picture for a landmark on the path or leave an audio message to call followers' attention on something. Once arrived at the destination, uploaded, your trace is visible to the public and can be downloaded from others. You can choose to share the trace with others. You can see all traces you downloaded from other people. Once arrived at the start location, check the start point pictures to make sure your start position and facing direction are correct. For future study, more reliable functionalities like how to search for traces, how to share a trace from parts guide, and how to calibrate the phone sensors are challenges in the future study.